Hello everybody. So today I'll be making what will probably be the last video that we'll need for the semester for the very last assignment. And normally I make I make my own slides for the videos and graphs and stuff like that. But for this section, I think that would be hard to do. So I'm going to make use of the textbook, okay? And you have access to the same book that I'm looking at right now through my math lab. And so if you wanted to refer to the same stuff that you see in the video on your own, you could do that. But I think it would be a little faster. And I guess I could tell you to just read the textbook, but it will be a little faster, I think, if I guide you through it, okay? So anyway, so the topic here in this last video is about scatter plots, okay? And within that topic of what a scatter plot is and what we do with it and the kind of things we notice about a scatter plot is correlation, okay? So scatter plots and correlation. Now, a scatter plot is made with paired data, okay? And that's data that it makes sense to, like, well, I guess two variables, all right, that make sense, at least in the outset, to go together, all right? So in other words, here's some data where it tracks the GDP of a country and the carbon dioxide emissions of that country, all right? And there have to be more limits. It's probably yearly, okay? Gross domestic product is a yearly number, a measure of the size of an economy. And CO2 emissions, like you should know what that is nowadays. You hear about it all the time, but carbon emissions from the same country. So it might make sense for those variables to go together. It might seem that the bigger an economy is, which is what the GDP measures, roughly, that maybe the more CO2 is emitted, okay? And if we make a scatter plot, then we might be able to see that that's true, okay? So we use a scatter plot for paired data. Now, let's see, let me show you some other examples. Like here's an example where the question is there a relationship between a person's height and their pulse rate, okay? And so here's some data from, let's see, 3, 6, 9 people, okay, where their height was measured in inches and their pulse rate was measured. And we can make a scatter plot and see if, in fact, maybe the taller a person is in general, that the higher their pulse rate is. Like maybe that's true. A scatter plot could let us find out if that's in fact true. Now, all right, so let's go back to this original example where we're trying to figure out, is there a relationship between the GDP of an economy, meaning a rough measure of the size of an economy, and the CO2 emissions from that same economy or country, okay? So we got this one country GDP at $1.8 trillion per year, and CO2 emissions 604.4 million metric tons, okay? That's for one country, two measurements about one country. That's how we understand this. And then another country, and another, and another, and another, okay? And then when I look at this graph, like every single point on this graph is one of these data points. You know, we say that one value is the X value and it goes on the horizontal axis, and the other variable is the Y value and it goes on the vertical axis. So when I look at this dot right about here, that looks like it's probably this one, okay? Where the GDP is 0.9 and the CO2 emissions are about 232. See this point right here? It's like just left of 1. That's why I think it's probably 0.9. And then vertically, it's just above 200, where the Y value is 232. But see, all these other dots represent each of these data points. That's what a scatter plot is, okay? Now, here's what I see. It does look like, you know, see how there's a rough upward trend here? You know, it's not perfect. I'm not saying they're in a perfect straight line, but roughly it looks like they kind of go up together like that. I mean, that's what I see. And then I can read into that a little bit further. I can say, well, okay, yes, the points, the little dots do go up and to the right, like roughly in a line. I can see that. You can probably see that too. And that means that as GDP goes up, then it looks like CO2 emissions go up too. And there are exceptions, like the dots don't line up perfectly. This dot looks like it comes from a country that has higher than normal CO2 emissions based on the size of its economy. It's like above the other dots, that are nearby it. And then this one seems like it might be a little low, all right, that based on the size of its economy, it seems like it might be kind of low for CO2 emissions. Because if I was going to connect a straight line to them, it might go like this. So some of the dots might be a little high, and some might be a little low, but their rough trend is in a line. So I think it's safe to say then that the trend that we see is that, yeah, as GDP gets bigger, so do CO2 emissions. Okay, so that's what a scatter plot is, and that's what it does. All right, allows us to see trends in data. For paired data, the plot represents the data points. One of the values has to be chosen as the x value, which is on the horizontal axis, and the other has to be the y value, which is on the vertical axis. Okay, now here's the kind of trends that we can see in data. So here, these are some sample scatter plots. They look kind of like the one that we were just seeing, okay? So we just saw one like this, where as one variable goes up, so does the other. That would be a line that is rising from left to right, and that's called positive linear correlation. Positive meaning both variables increase together. Linear meaning it's roughly in a line. Like I told you, it's not going to be, probably not going to be perfectly in line, but yeah, roughly in a line. And correlation meaning that we do see, in fact, a sort of a cause and effect pattern between them. Okay, maybe you've heard before, correlation doesn't prove causation, but we can think of correlation kind of like that for now. So, and then here's the other kind of linear correlation that we might see: negative linear correlation. Negative meaning that, well, think about it. So if the points go down and to the right, then that would mean as the x variable got bigger, the y variable got smaller, okay? So if it's a negative correlation, as x gets bigger, y will get smaller, okay? That's what the negative part means. Linear means they're roughly in a line, and correlation. Okay, so those are the two kinds of linear correlations that we'll see. And maybe there's no correlation. Look how these points are just scattered around, like it just looks like static or something, okay? No correlation, all right? There's points all over the place. And here there's a pattern to the points. I look at that and I see a pattern. You probably see a pattern too, but it's not a line. So, maybe there's some kind of trend, some kind of effect between the variables, but it's not going in a straight line or anything close to a straight line. This is a curve, an arch of some sort, okay? All right, so that's the kind of correlation that we'll see. Now, let's look at a few more examples. So let's see. I wanted to find, there was one in here that I saw where it really wouldn't make sense to have any correlation. And I'm trying to remember where I saw it. Okay, so it's this one. So we conduct a study to determine whether there is a linear relationship between the number of hours a student exercises each week and the student's grade point average. And it's a curious question. Maybe you'd think that the more you exercise, the more you care about your health and well-being, and maybe perhaps that includes your grades, okay? But then somebody might say, well, the more you study, like the higher your GPA is, maybe the less time you have to spend exercising. So maybe there's a negative correlation, a negative linear correlation. Who knows? So, well, that's why we conduct studies like this and make scatter plots. So this is paired data. for each student, where there's two variables we're going to measure, the hours of exercise and the GPA. Okay, and then here's the data and so on, and here's the scatter plot, and I don't see anything there. I don't see a correlation of any kind. Okay, I mean, so look, there's this like person who doesn't exercise at all that got almost 4.0. There's a person that does a little exercise, got a perfect 4.0. There's a person that does a lot of exercise, got almost a 4.0. There's somebody that does quite a bit, but less than 2.0. It just seems like the data is all over the place. No trend. It's not like as one goes up, so does the other, and it's not like as one goes down, or as one goes up, the other goes down. Sorry. Okay. Now, one last thing. There is, like you might say that if there is a linear correlation, that the data could be aligning itself more or less into a straight line. So like here, like I'm saying I see a line right there. And of course, it's not a perfect line, as I was saying. But I might say like, well, these points seem to form like a little bit tighter formation of a line, okay? And these points, I do see it as a rough pattern of a line, but it's not quite as good as this picture over here. So we like to measure like how tight the formation of the points is, or how much they align themselves into a straight line. And we do that with this thing called the correlation coefficient, all right? So that has an unbelievably complicated formula. It's right here. But in this class, we're going to use StatCrunch to do that. So here's something that I was alluding to just a minute ago. All three of these have a positive linear correlation, I would say. And all three of these, or sorry, each of these have a negative correlation. And then here's one with no correlation, okay? So here's the story. Yes, each of these do have a rough positive correlation, okay, linear correlation. These are all perfectly in line with each other, okay? And it makes sense that these are all perfectly in a straight line because the variables are the number of movie tickets that you buy and the total cost. And it's like, it's not like you get a discount generally the more tickets you buy. So you buy one ticket and I don't know, it looks like it might be about like $8.50 or so, I can't tell. And then you buy two tickets, it's going to be double that. Okay, it's going to be $17. And you buy three tickets, it's going to be triple that. If you buy four tickets, quadruple. And those numbers have to be in a perfectly straight line. They can't like jump up and down off the line. Okay, so if you were buying like gasolines like that, the total cost you spend to fill up your tank depends on the price per gallon of gas. And if you were to plot those values, 1 gallon costs how much, 2 gallon costs how much, 3 gallon costs how much. Those numbers would be in a perfectly straight line on a graph. Okay, so now if you calculate this number called the correlation coefficient for data that's in fact in a perfectly straight line, if you graph it, you'll get a correlation coefficient of 1, okay? Here, these values are obviously not in a perfectly straight line, but close enough. There is a linear correlation there. And we're going to get a correlation coefficient a little bit less than 1, okay? And the worse the formation is between these points, the smaller the correlation coefficient gets. So if it's perfectly straight, we get R to be 1. If it's scattered a little bit from a straight line, we'll get R to be somewhat less than that, like 0.81. And if they're scattered even more, it goes down from there, okay? So the correlation coefficient measures how tight the formation of points are in a line, okay? The closer it is to 1, the tighter the formation is into a line on a graph. Now that's for a positive correlation, okay? For a negative correlation, the correlation coefficient will be a negative number, okay? If they are points in a perfectly straight line, but going down and to the right, then it will be a negative correlation, and your R value, your correlation coefficient, will be -1. Here, well, they're obviously not in a perfectly straight line, but it's very suggestive of that, and we get a correlation coefficient of -0.92, okay? And if these points were scattered even more, we would get a smaller negative number. All right. Now, if there's no correlation at all, you'll get something close to 0. That's how the correlation coefficient works. The closer it is to 1 or -1, the tighter the formation of points is into a line. If R is positive, it will be a positive linear correlation. If R is negative, it will be a negative linear correlation. And if the R value is close to 0, then that would mean that there's no pattern, no correlation at all, okay? All right, so that's what the correlation coefficient does. Now let's look at how we can do some of this in StatCrunch. So let's see, so I had this open. All right, so here's a question where we get some data, and it says the accompanying table shows the ages of 11 children and the numbers of words in their vocabulary. Okay, so I think the older the kids get, the more expansive their vocabulary is, but let's see. Let's look at the data. So here's the data. Oh, whoops, okay. Here's the data. All right, age, a 1-year-old that has 4 words, a 2-year-old that has 220. Okay, so that's like the measurements, the variables for these particular kids. Now let's see if it's right. My instinct is correct in the study that the older the kids get, in general, the more expansive their vocabulary is. I'm going to open this in StatCrunch. Okay, and then there's the data that we were just looking at. Now, the question was to make a scatter plot, okay? That's what we were talking about at the beginning of the video. So I'm going to choose, I go to graph, and I choose scatter plot, and I have to select the variables. So I want age to be the X variable. I mean, that was how it was indicated in the data table, that we want that to be X. We want that to be the horizontal variable. And vocabulary size, we want that to be the Y variable, so I select accordingly. And the rest of this, I guess you can fine tune everything if you want to, but I like it the way that it is. And all I have to do is select the variables and compute, and there it is. Okay, yeah, I'm seeing a line like that, you see? I'm seeing that, although it's not perfect, that as age increases, so does number of words in the vocabulary. Okay. Now it should be easy from this picture to select which one we just saw. Well, it wasn't this one, and it wasn't this one, and it wasn't, I mean, it's definitely A, right? So, you know, that part, I mean, as long as we know how to do it in StatCrunch, not so bad. Then it wants us to calculate the correlation coefficient. Okay, so let's go back to StatCrunch. And we can do that through calculators. Okay, I gotta remember. Summary stats. Okay, summary stats and correlation. Okay, and I need to select both of these. Okay, not just one or the other. And I don't have to say which is which. I don't have to say that one of them is the X value and one of them is the Y value. Just select both of them, doesn't matter. And then I don't have to mess with anything else. And I compute it, and there it is, 0.97967, so on. And that's not too surprising, because I remember when I had that original graph, yes, they weren't perfectly straight. The dots didn't line up like somebody put a ruler over the paper and drew a line, but it wasn't too far from that either. So 0.9697, let's see, what are we supposed to round this to? It says to round to 3 decimal places, so 0.96 or 0.979, so that'll be 0.980 if I round to 3 decimal places. 0.980, let's see. All right, there we go. Okay, let's describe the type of correlation. Well, that was, remember, the as we saw the line up here, generally up and to the right. Another way to say it is as age increases, so does vocabulary. As one variable increases, so does the other one. And we call that a positive linear correlation. And I guess if I had to say something more about it, it wouldn't be that it was perfect because the data points didn't line up in a perfect line, right? But it was pretty strong, so that's what I would say about it. Uh, my correlation coefficient being close to 1, remember the most it can be is 1. And either way, like no matter what kind of linear correlation it is, the closer you are to 1 or -1, the better the correlation is, and the more tightly the points are aligning into a perfectly straight line, okay? Whether it's close to 1 in the case of a positive correlation or close to -1 in the case of a negative correlation. All right, now I've said, given a lot of it away, I'll let you do the next part of it. Okay, let's try another one, okay? And just for a variety, and I want to show you another example. So in the table, we see the height of 8 high school girls in their IQ tests. Okay, well, I don't see those variables going together. I don't see there being a correlation, okay? Sure, you can take 8 people and you can measure their height and you can measure their IQ and you can make that into points and you can put the points on a graph and you can call it a scatter plot. You can do that. I don't think you'll see a pattern though, all right? I mean, I kind of think B might be the answer, but I mean, I wouldn't say any of these are real strong. Maybe like A or B, but let's see. Maybe I'm wrong, and that's why we make, I'm sometimes wrong, sorry. And that's why we make scatter plots, is to see if maybe there's a trend between two variables that we weren't aware of, okay? So here's the data, all right, and I definitely want that to be in StatCrunch, so I open it in StatCrunch. There's my numbers, and I'm going to do a graph. I'm going to do a scatter plot, and I want height to be X and IQ to be Y, and I don't have to do anything else, and there it is. I mean, maybe these points roughly like a weak positive correlation, but then like this point we would call an outlier, because it's like if there's a trend among these, this one is for sure an exception to the trend, and that's what an outlier is. Well, okay, I mean, that's it. I mean, I guess there's more of a trend than I expected, but okay. Let's see if we can select which one of those it is. It's this one, right? There was that one outlier up there. It was about between 120 and 130, okay? And then the others had like kind of a weak positive correlation. Okay, correlation coefficient. All right, let's do that. Here we go. So we did that under calculators, or no, summary stats and correlation. Okay, so I choose both of these and I just hit compute, and look how close to 0 that is. So even if, because I guess like visually I could be deceived by this, because when I had that graph, I said, it seems like there's kind of a weak correlation, a little bit maybe, but this number is really close to 0. So no matter what I see, this tells me that there's not much of a correlation. There's not much of a trend between those two variables, because for there to be a strong correlation, either positive or negative, you have to get a correlation coefficient close to either 1 in the case of a positive correlation or -1 in the case of a negative correlation. And this is close to 0, and which means that there's no trend at all, or close to there being no trend at all, okay? All right, so I get 0.065 if I round to 3 decimal places. Let's see, 0.065. All right. And StatCrunch did all the math for me. I just had to type in the number, and there it is. So describe the type of correlation. There is a, let's see, I would say no linear correlation at all. And I guess there's not hard boundaries to this, but if I see a number there less than 0.1, I would definitely say there's no correlation. But yeah, that's closer to 0 it is, the more we can say with confidence that there's no correlation. Okay, anyway, now so that's what we're going to say about scatter plots and linear correlation. Let me know if you have any questions.